Let's see how you did on these. So remember, the key to these is you're looking at figuring out how the equation was put together, how it was built. Remember, all equations start out as a variable equals a number. We're trying to get it back to that state. So one like the first one up here, number 1, we look at which side of the equation has the variable on it, and that's over here on the left. And then we look at what's keeping that variable from being by itself. In this case, it's the 7 and the 3. Then we ask, what operation attaches each of those? Well, the 7 is multiplied, and the 3 is subtracted. So this equation was built by taking the variable, multiplying it by 7, and then subtracting 3. To take it apart, we have to reverse that process. So the last piece that was put onto this, was built onto this, was subtracting 3. So that's going to be the first piece we take off. And we're going to do that by adding 3. So that's gone. So now all that's left over here is the 7x, because the subtracting 3 is gone. 39 plus 3 is 42. And then divide by 7 to get rid of the multiplying by 7. X equals 6. How many of you had the x equals 6? Now, of course, from there it gets more complicated, because here we find the equal sign. We go to identify which side has the variable on it, and we see the x's on both sides. So we have to get rid of one of them, and we generally choose to get rid of the smaller one of the two, which is going to be the 5x here. So I'll subtract 5x. Would it matter? Would I get the same answer if I subtracted the 7x? Sure would. I'd just be dealing with negatives instead of positives. So over here, all I have left is 2. 7x minus 5x is 2x minus 18. Now it's just like over here. I got two things to get rid of. What am I going to get rid of first? 18. So I add 18. 20 equals 2x, and then divide by 2. 10 equals x, or x equals 10. How many of you had that one? Okay. You did the other way around, but you still had it? Yep. Because it would be negative 2x equals negative 20. And so negative 20 divided by negative 2 is still a positive 10. Yep. So now, on the left side, we've got parentheses to deal with. And on the right side of that one. So just like we did with number 2, sometimes we have to adjust things before we start to solve. Here we got some things to combine and simplify. So there's nothing to do inside this set of parentheses. So we're going to multiply by the 2. 2 times 3x is 6x, and 2 times 11 is 22. Equals, over here we've got 5 times x, it's 5x. 5 times 7 is 35. Now what do we need to do? Get rid of one of the x's. We'll get rid of the smaller one, is the 5x. So over here it's gone. All that's left over there is 35. Over here 6x minus 5x, 1x, or just x. And we have the 22. Now what? Yeah, 22 is added, so we're going to subtract 22. X equals 13. Now in any of these, if we're not sure if we did it right, we can always go back and put the value back in for x. If we put 13 in here and 13 in here, do we get the same number, the same numerical value on each side? And we should. It should come out to be 100 on both sides there. Over here, we find the equal sign. We see what's been done to our variable. Here, z has been divided by 3, and then 2 has been added to it. To solve it, we're going to subtract 2, because that was the last piece that was put on. That's gone. Subtracting 2 over here gives us 4 equals z over 3. Then what? Multiply by 3. So that's gone. 4 times 3 is 12 equals z. Any questions? We were solving equations of that form So 3x minus 5 equals 13. And when we solve that equation, we added 5 to both sides, leaving us with 3x here, making this 18. And then we divided by 3. It's called literal equations.
Literal?
Literal equations, or rearranging formulas is another way of wording it. So you divide the 18 by 3, you get 6. So x equals 6. Well, there are a lot of times you deal with formulas that are not in the form that would be simplest for you to use. For example, let's say that this formula here, this equation, the 3, the 5, and the 13 come from other pieces of information that are going to change depending on the situation. So you might label it as ax minus b equals c, where a, b, and c are found from something that are coming from the situation you're dealing with. And if you're going to have to calculate x from those values over and over again, it would be easier to have this in terms of x equals and then have just a formula where you can plug in a, b, and c and do order of operations and be done, and not have to solve an equation. Well, if you look at this, again, this equation here is exactly the same form as this one here. I just put letters in there instead of the numbers. To solve it or rearrange it, I'm going to take the exact same steps I did over here. Here I added the 5 because I had the minus 5. What am I going to add over here? B. So the b is gone. I have ax here. Now the difference is, over here I was able to do 13 plus 5 and get 18. Here I got c plus b. All I can do is write that as c plus b. There's nothing more I can do with it. This next part is the part that kind of puzzles some people. I have to divide by a to get rid of a. So I divide by a and it gets rid of it there. When I multiply or divide, I have to multiply or divide every piece on each side. When I add or subtract, I only have to add or subtract from one piece on each side. So I divide by a, I have to divide that whole side by a. So that equals, I can either do c over a plus b over a. That would be fine, like that. But it's simpler to just leave it as c plus b all over a. So now once I have values for c and b and a, I can just plug them in, I add c plus b, and then I divide that total by a. Now again, if I was only going to have to do this once, it would make more sense to leave it like this, plug in the a, b, and c, and solve it. But if I was going to have to do it over and over again several times, in this form it's easier to just plug in the numbers and do my quick order of operations. So here, v equals IR. Most of the time, we're going to have a formula like this where what we're solving for is not x. So we have to be told what we are going to solve it for. So if I tell you I want to solve this for r, what's keeping r from being alone? The I. What operation attaches it? Multiply. So to get rid of it, we're going to divide by I. So the I is gone. We have just v over I equals r. Now something we haven't really seen yet is something like this, where we have, well, we've seen a little bit of it, I guess, but x squared equals 9. What's been done to the x there? It's been squared. So how do we undo that? Square root it. The square root of x squared is just x. Square root of 9, 3, or negative 3. Now for our purposes, we're going to be okay if you just put down the positive one, that's fine. So what if we have p equals I squared times r, and I want to solve this for I. Now, two things have happened to I. I has been squared, Then it was multiplied by r. To take it apart, we're going to reverse that. We'll divide by r. So r divides out. So I squared is over here. P over r is over here. And yes, then we're going to square root it. Now be careful, we got to square root this whole side. A lot of people just put the square root over the p. It's the whole thing's got to be under it. So the square root of p over r, there's nothing we can do with that. But the square root and the squared cancel out, and that's just I. So the square root of p over r equals I. The tougher ones to work with are if we have something like this. In fact, let's do a simpler one first. Like this. And I want to solve that for f. Well, since this is in a proportion right now, one fraction equals another fraction, to solve for f, I can treat that as though that's the missing number, and I would just cross multiply and divide. So b times ct is just bct divided by m, and f equals that. How about something like this? Q over C equals P, and I want to solve it for C. Well, I can make this just like the one above. I'm going to put P over 1. Now it is a proportion. So I am solving it for C. So I'm treating this as though this is the blank spot. So when I cross multiply, what two numbers get multiplied? C is what I'm solving for, right? So I'm going to leave that as my blank spot. So Q times 1, which is just Q, and then I divide by P. So C equals Q over P. So I got M over CT equals L, and I want to solve for T. So I'm going to solve for T here. What I can do is this. I'm going to actually treat CT as my blank spot, and I'm going to put L over 1. So I'm going to cross multiply. M times 1 is just M divided by L, right? So right now, CT equals M over L. I want to get rid of what over here on the left? I'm solving for T, so I got to get rid of C. I'm going to divide by C. Dividing by C over here. So now if I've got M over L divided by C, that's M over L times, I treat that as C over 1. I'm going to multiply by the reciprocal, 1 over C. M times 1 is M. L times C is LC. M over LC or M over CL, however you want to write it. This here is actually a very common formula in statistics. You might be wondering, why do I care about statistics? Well, for you guys, statistics will come into quality control, statistical process control involves a lot of statistics. A lot of manufacturing facilities use a system called Six Sigma for quality control. That involves a lot of statistics. So here I have the formula, the margin of error equals Z times S over the square root of N. And I want to solve that for N. So I've got to whittle this away. If I start with n has been square rooted, but I can't get rid of that right now. The first thing I need to do is I need to get this set up as a fraction, or as a proportion. So what I'm going to do is this whole part here, the parentheses have been multiplied by z. I'm going to divide by z. So what I have here is e over z equals s over the square root of n. Now I'm solving for n, so I'm actually going to solve for the square root of n right now. What do I have to do? Z times s over what? What am I going to divide by? Cross multiply z times s, I'm going to divide by the e. So the square root of n equals that. Now I'm going to pause there. Anybody have questions on how I got to that point? So I was solving for n, so I just isolated the square root of n, and then cross multiplied and divided the other three numbers. Now what do I have to do to get just n? I have to square it to get rid of the square root. So the square root and the squared cancel out, so n is equal to z times s over e, all squared. Or you could do, we saw with our other variables, you can square each variable separately. So you could do that z squared times s squared all over e squared. But to me, it's just as simple to leave it like that. So let's say your surface cutting speed is equal to pi times d times your RPMs all over 12. I put in F for your surface cutting speed, I'm doing feet per minute. And I want to know, I want to solve this for n, for my RPM. What's the first thing I got to get rid of? Well, n, and when this was put together, it was multiplied by pi and d on top. Then it was divided by 12. So to reverse that, I have to multiply by 12. So 12 times f is 12f equals pi dn. And then I'm going to divide by pi d. So I've got 12f over pi d equals n. Now you guys use what, 3.82f over d? That's just 12 divided by pi, is 3.82. But you can see where it comes from. Make sense? Okay, so for you guys to play with these a little bit, in the book, I believe it's page 392 to 394. Exercise 15-4. Want to do the odds in there? Give you some practice of rearranging formulas.